Hey, what's going on? It's Justin Dickmeyer with engineeringtrainingexam.com. And in today's video, we're going to work a fluid mechanics practice problem. The problem states, air at 20 degrees Celsius and 1 atmosphere has a density of 1.2 kilograms per meter cube, flows at 20 meters per second past a flat plate. A pitot tube placed 2 millimeters from the plate developed a manometer head of 16 millimeters of Merriam red oil, which has a specific gravity of 0.827. Assuming laminar flow, determine the local velocity at the inlet of the pitot tube. The topic of fluid flow measurement falls under the main category of fluid mechanics. Equations, symbols, tables, and information on the various topics covered in fluid mechanics can be referenced on pages 99 through 112 of the NCEES Supplied Reference Handbook, version 9.2 for computer-based testing. In this problem, we are looking for the velocity of the air as it enters the pitot tube. We can get all the equations we need to use that relate to the pitot tubes and manometers directly from the NCEES Supplied Reference Handbook. Specifically for manometers, reference page 100. For pitot tubes, reference page 107 of the NCEES Supplied Reference Handbook. These are the two equations that we will use with the information that is given to solve this problem. This problem gives us the following information. We have the density of the air, which is 1.2 kilograms per meter cubed. We have the specific gravity of the oil at 0.827. With this, we can determine the density of the oil by multiplying it by the density of water, which is 0.827 times 1,000, and we get 827 kilograms per meter cubed. We also know the manometer head is 16 millimeters, which we convert to meters, which is 0.016. Assuming constant stream pressure, the manometer can be used to estimate the local velocity at the position of the pitot inlet. The first step is to determine the difference between the stagnation and static pressure of the manometer. With the equation we are given in the NCEES reference manual, we can rearrange and use the equation and just plug in the information that is given. I've dropped the units here, so pay attention to that. But we find that the difference between the stagnation and the static pressure is 130 pascals. Again, I did drop the units, so double check that your units are good. Plugging this value into the velocity equation for a pitot tube, we find that the velocity at the inlet of the pitot tube is 14.7 meters per second. And that's it for this video. I hope you enjoyed it. If you need more information on the FE exam, hop on over to engineeringtrainingexam.com, where we have plenty of FE exam study resources, strategies, and tips, as well as a free course. And if you're not a subscriber here on YouTube, make sure you hit that subscribe button and be looking out for future videos. Take care.